very warm welcome to all our viewers to this Times Network special. I'm Deepak Bopana and with me is my colleague Dharani Balasubramaniam. Today joining us is a guest who's one of the most brilliant minds in the country. Now he at this point in time is shouldering the hopes and aspirations of 1 billion Indians. Well, more importantly of course, he's now planning to write a new chapter in Indian space odyssey. We have none other than Mr. Somnath, the Chairman of ISRO, joining us. Thank you so much for joining us today, sir. It's a big event that's coming up, the launch of Chandrayaan-3. Of course, we're going to be talking in detail about that. But how's the mood right now at ISRO? And how's your mood? I'm sure, you have a lot of meetings that have been lined up, a lot of preparation to do. Just walk us through this, because according to me, it's probably a cricket match or a World Cup final where, the entire country is waiting with bated breath to see this succeed. And the same thing is happening this time around. How do you really feel? How are you dealing with this pressure?
See, today there is no pressure for us. We are working the way we used to work for launches. We build rocket, we launch them regularly. This year we had 4 launches already. And the Chandrayaan-3 preparations are going on very well. The LVM-3 is ready and it's at the launch pad undergoing final testing processes. You also know that at the same time we are also preparing another rocket, PSLV, for launch immediately following it. And there are other preparations for subsequent launches as well. So it is a professional work that is happening in ISRO on building rockets and satellites and launching. But as you already said, that there is a high mood of expectation of all the people for this mission specifically. And we have taken all due care and simulation test and all things that we can do to make this mission a grand one. And we are hoping for the best.
Well, Dharani, why don't we, Dharani, of course, my colleague joining us from Chennai, she's been, tracking all the movements happening at Sriharikota and much more.
I travel frequently to Sriharikota.
Go ahead.
Sir, it's very fascinating to know that we are traveling over 380,000 kilometers for a third time. And it's a dream project not only for the ISRO, but, for the whole country. So if you could, give us some insight into the goals and objectives of Chandrayaan-3, what you're, working on, that will be helpful.
Chandrayaan-3 has a similar goal as that of Chandrayaan-2, with some small variations in terms of the scientific objectives that we want to do. Last time in the Chandrayaan-2, we could not achieve the soft landing, and hence the lander and the rover, where the scientific experiments were incorporated, could not be accomplished. So this time what we are doing is those missions, those part of the mission is the focus, achieve the soft landing. Then after the soft landing, rover and lander will do the scientific experiments, send the data to us. So that's the primary objective. So, and the orbiter part, which was launched last time, is still working very well, the Chandrayaan-2, and has provided information, scientific data, which is actually being used by scientists all over.
So, but I must ask you, of course, you must have been asked this question multiple times. After the failure last time, it must have not been easy on the scientists at ISRO. And, they say space is unforgiving and the margin for error is almost nil. How do you really bounce back from a situation like that? And what have you really learned from, the lessons that you've learned from that?
Failures are always difficult. As you know, there are a lot of questions asked, whether did you do it properly? There were any, any errors that could have been avoided. No, your understanding level, was it proper at that point in time? All these questions do come. And unlike any other accidents that you happen on a terrestrial situation, the hard landing on moon leaves no proof to us immediately. But of course, we can reconstruct through the orbital data, and what could have happened are scenarios that we find out by simulation. And the scenarios we found out over the last many years, and it has been a very tedious work. Our first part was establishing what went wrong, and that went through very rigorously, bringing in a lot of experts from ISRO and outside, and we could reasonably find out what could have gone wrong. We also looked at what can wrong further than what actually happened. There were any resident errors and resident issues that could have manifested otherwise. So all these were the second part of the journey. The first part is establishing what went wrong. Second part is what can go wrong and how do we really do this modification, and then do the modification. Then final part is test it to a perfection, to a level that we have not done before. So all this happened in the last two years plus, and we made the next craft, the lander, the orbiter, and the rover again, except with that orbiter part is slightly different. Without the the scientific experiments on board. And the rover also went through a series of testing, simulations to a higher level of dispersion handling capability, and we are there now with the Chandrayaan-3 on board LVM-3. So it has been a very, very tough journey for the entire team of Chandrayaan-3 project. They went through very rigorous, unforgiving lessons in their life, answering so many questions and reviews, etc. And I am very sure that through that process they would have become stronger.
You have to be a master, isn't it? Because you have to tell them that there is no room for error.
See, we always tell this because the space, as you mentioned, the crux of the problem is that there are thousands of things happening in it, and there are so many variables that are there, and your ability to foresee a priori and design it with very low margin is the art. So we don't have very high margin like terrestrial structures or systems, but in space we need to keep the margins very low so as to save mass. And it still has to handle uncertainties beyond those margins. So this is a tough job. So we'll have to predict how much things can go beyond our expected boundaries and how to take care of it. So this is the art at which we have perfected now. There were certain level of boundaries that we designed last time. Now this time we have to expand the boundary. And when you expand boundary, it has its own implications like increased mass, increased power, increased overheads. So we have to handle that with the available capability of the rocket. So this is the thing that we did.
Sir, in terms of the build and the technical capabilities, how different is Chandrayaan-3 from Chandrayaan-2? And also talking about the landing spot, which spot in moon are we planning to land, and why did we choose that spot? What is the reason behind choosing that spot?
You are on your first part of the question related to the change from Chandrayaan-2 to Chandrayaan-3. Essentially, the same three constituent elements of the Chandrayaan-3, like the orbiter, which is now called the propulsion module, the lander, and the rover, are still there. The orbiter part is not having any significant payloads like last time. Its primary job being take the lander and the rover to a 100-kilometer orbit around the moon after the injection to the Earth orbit.
And we have improved the propulsion module this time.
This time the propulsion module is not improved. It is we removed the payload elements and it is given task only to do the function of reaching it up to the moon. And the second part is the the lander is now heavier by almost 200 kilogram plus. What we did is there are many more changes done in the lander, primarily to handle higher velocities of landing. Then it has more energy generating capability like solar power capability. It has more propellant to handle dispersions and propulsion uncertainties. It has new sensors which will take care of the sensor failures if at all it happens. It has new algorithms and software sitting there which are made wider to handle. Its control and guidance algorithms and softwares have been modified and capable of handling multiple paths of travel to reach the land, etc., etc. So essentially these are the changes. The scientific part of the experiment, the payloads on board lander and rover are one and the same.
So the
landing spot is also almost the same because it is almost 70 degrees to the South Pole. And this location has been selected last time also, where there is sufficient illumination of the sun, but it is closer to the South Pole, where we have more scientific interest, because the equatorial region, which is very safe for landing, which is enough solar power and the risks are lower, has already been surveyed and a lot of scientific data is already available. So if at all we have to make a very significant scientific outcome out of this mission, it is better to go to the pole. And why? That's why we selected a place closer to the pole, but it has higher risks of landing safely. But then, of course, we have tried last time, so we didn't want to make a change at this time, and this has been well studied. And mind you, I want to tell you that we have now the Chandrayaan-2 orbiter still there, and it is providing enough data, like the very high resolution images of the moon where we are likely to land are already available with us. And this data has been well studied, and we have incorporated a lot of inputs from Chandrayaan-2 into Chandrayaan-3 on this part of the landing site, how good it is, how many boulders or craters are there, and we have widened the domain of landing for better possibility of landing.
So now the Russians, the Americans, the Chinese, they've all carried out lunar missions. How different is India's lunar mission, this particular Chandrayaan? What are we looking to study? What are the kind of intel that we'll gather from this? Share this insight with our viewers.
See, moon has been well studied. I think the astronauts from US have gone many times to moon and collected samples and brought there. Russians have not gone physically, but they have sent robots there, and other nations also did. But mind you, our Chandrayaan-1 discovered the presence of water molecules on the moon. So if you ask this question, what you are going to find new, there is always an element of surprise in this. So what you can find is always dependent on how good your instruments are, how good your ability to detect new scientific findings are. So, and we have identified specific scientific objective in the mission which has not been done before. So that is an interest. And more importantly, there is an increased interest in moon from everybody, even now, even after it has been explored. So the extent of exploration that others have done are limited. Let us understand that. Because some few missions to moon doesn't mean that you understood everything about the moon. So there is still significant scientific interest on moon. So this time we are looking at specifically on the regolith. The physical characteristic of the moon surface is what we are focusing on. And very close to that surface, the atmosphere, the characteristic of the atmosphere. And we are also looking into the tectonic activity. That is like we have a very sensitive acceleration measurement system which will measure what is happening inside the moon. So these are the three physically, measurement scientific objectives. With 5 instruments we are trying to do this. I am hoping that there is something new we'll find out. So we will also find out the elemental composition of moon, which has been somewhat studied, but there are other ways of doing it in better manner. So this is on in situ evaluation, which we are doing this time. But the most important part of this is that there is a growing global interest in moon, and we being a very leading space nation cannot go behind, and we need to demonstrate our capability to reach this uncharted lands and establish our own flag on the place. I think that is very important.
Sir, if you can shed us some light on the challenges that were faced by ISRO during the making of Chandrayaan-3. What did we go through? Now that the satellite is ready, the rocket is ready, but if you can shed us some light on the challenges, the path, the journey.
See, after the last Chandrayaan-2 mission, then the effort of understanding it and making correction has been very, very difficult. The most important thing we did is we charted a set of tests over the last 1.5 years, 2 years of time, is to conceive those new tests and then execute them, which made us to make many models of the Chandrayaan-2 lander, and it went through a series of tests. One of the important tests I can tell you that we flew the entire thing on a helicopter over a terrain to simulate the travel of the lander on the moon and how the entire instrumentation will work while it is actually moving on the surface of the moon. So this is one important measurement, and we found a lot of interesting outcome out of it, which helped us in modifying many of the algorithms and sensors. The second test is using a propulsion module. We had to simulate the landing process. And this landing process we have not done earlier with entire elements of the lander in that. We tested only the propulsion system. But this time we thought that we will put the sensors, the electronics, everything on board and see the interaction between them. And we have to conduct this test in various simulation conditions, including terrain simulation. And so there was many tests which was been successfully conducted to do this. The third was in landing, how to land on surfaces which has boulders, tilt, and the regolith, the surface which is texture, which is similar to that of the moon. So we simulated a test, created test beds, then strengthened the entire landing lug and its energy receiving capacity almost significantly higher. Then so many tests were done to the limits of its performance and strengthened the landing legs as well. And the other most important thing I can tell you is development of a new measurement system on board Chandrayaan-2 to find out the velocity. Earlier we had only camera which will look at the terrain of the moon and then find out based on the images, we can find out what is the speed. Unlike a car which is driving on the road, the speed is measured by the rotation of the wheel on the relative movement between the wheel and the earth. If the wheel is not touching, you cannot measure the speed. Only inertial system can measure the speed. So the relative measurement between surface and this is done by the camera. But this time we have introduced another interesting measurement called laser Doppler velocimeter, which actually measures the velocity in 3 directions using a very new instrument we developed in-house, and that is being used. So all this happened last 2 years.
Okay.
So you of course explained to us a bit about the difference in, you said the orbiter is not the same as it was before, but as far as the rover and the lander is concerned, talk us through how is it going to really be different, or what kind of information will they be able to gather? How much can the rover really move on the moon surface?
Okay, there is no much difference in terms of scientific instruments like last time. So after the rover coming out, we will be seeing it using the camera on the lander, And
So will our viewers be able to see it? Is it going to be broadcast?
it won't be a real-time broadcast because there is some
Delay.
amount of processing delay, but it will be reasonably real-time for you to see. But then we will ensure that the rover moves only within the vicinity of the lander for the time being, because we have to only look at some of the typical terrain where we need to do the experiment. We don't have to move far away. I think the far away is not an objective at this point in time. And it is going to live there only for the first lunar day. So we have to complete the instruments testing and also conduct the actual experiments in very short possible time. And then try to move where the camera visibility is still there. And if you find any interesting objects there, like the boulder, etc., where you want to go, I think those decisions
so
can be taken.
maneuverability, of course, will be very high in terms of the
still
rover.
there. So we will look at it, what all we can do within the location. But if the location where we are landed is not that very safe for doing a lot of maneuvers, possibly we may not do. So it all depends on where exactly we are landing. Are we landing on a slopey terrain? Are we standing on a boulder-filled area? All this will be decided at that point in time.
In the layman's term, do we consider a rover to be similar to a monster truck which can go on any sort of terrain?
It's not exactly like that. It is actually a very small baby. It doesn't have the capability to maneuver and push rocks and find its way through that terrain. It moves extremely slow with a very low power. It has a very small battery. It has 6 wheels. It just weighs 26 kilograms. So it's not very massive object that can move. And the ability to generate power is also limited. It has a very small solar panel. So it has to find power from the sun and then fill its power pack and then move. So it won't do continuous movement. It will move for some time, stay there and do some measurements, again move based on our command.
Sir, are there any international collaborations planned for Chandrayaan-3, sir?
For Chandrayaan-3, there are no scientific collaboration because everything on Chandrayaan-3 is made in India, including the instruments and scientific objectives. But of course, we collaborate with many other agencies in making use of this data for study and analysis, which will definitely be shared with others. And also, we take help from other nations and other agencies for the mission, like the deep space navigation support, which is required for this mission, because using India's alone navigation setup, deep space navigation setup, we cannot see it all the time. And also for failure scenarios, so in case our system fails, there must be some redundancy for it. And we also involved the other agencies for reviewing our design and the approach that we are taking this time, so as to make more doubly sure that whatever we are doing is right. But of course, their amount of inputs that we can receive are limited. But by and large, they said that yes, they are happy with our approaches and algorithms and decisions that we have taken to make the changes and modifications. So such interactions do take place with the other agencies.
So moving a little away from Chandrayaan, we believe that India and the United States, they have been working towards sending an astronaut to the International Space Station. How far have we come then? Also, of course, the 4 astronauts that are being trained as well from the Indian Air Force. Give us a little bit of details about these.
Well, this is a very important announcement that after the visit of our Honorable Prime Minister and the discussion that followed with the President of the US, that an intent for taking one of our astronauts on board the International Space Station has been arrived at. Now we have to work out the rest of the details, which includes the training program, how many of them will undergo training for the human space flight, and how long they will spend time on the ISS and which vehicle will take them, what scientific experiments they will do, and along with them whether other people will be trained, and whether it will be a one-time flight or multiple times flight. All these are under discussion at various levels between ISRO and NASA. And we are hoping that we will be able to conclude it in short time and arrive at a implementing arrangement or MOU or whatever before by next month or so, or maybe not more than 2 months.
Sir, there's also the mission to the sun called Aditya that's coming up. Can you give us a sneak peek into what's happening with that mission? Like, how far are we in that?
The satellite is currently under integration. All the payloads required for the mission have been delivered. Aditya L1 satellite is at our UR Rao Satellite Center. It will go through final testing, and it also has so many integrated level tests like thermovac, etc. And after that, we are planning to launch it in August. The launch vehicle campaign, building it has already commenced. So it's a PSLV mission, full-fledged mission. And it will launch it to the Lagrangian L1 point, which is also similar to the launch like we are taking place in a geosynchronous orbit, a very highly elliptical orbit, which will be further taken to an still bigger orbit, which is almost 3 times the distance of the moon. So it has to travel that much distance. So it will go there and get captured at around the L1 point. So we are looking at studying the moon using the very interesting instrument that has been designed jointly between Indian Institute of Astrophysics and ISRO. And also there are instruments designed by ISRO as well on board.
Sir, in the same line, if you could shed some light on the Gaganyaan project, like where are we there?
Because I think the anticipation among the people is when are you going to put an Indian or a human in space? Because that's a question that's repeatedly asked.
Yeah, we are working very seriously on this project last 4 years or so. As you must realize that it has many elements of development. It is not preparing the astronaut, and we have to prepare the vehicle and operate it to a level called human rating, and this process is currently going on. And you would have noted that LVM-3 has been making other launches as well, which was not originally intended, and we are doing the commercial mission, including Chandrayaan mission at this point in time. We have development of many systems happening, the crew module where the crew is going to live, the crew escape system that handles accidents of the launch vehicle to save the crew. We are also developing the integrated vehicle health management system, which will look at how the rocket is going to fail and how to take the crew away, and that intelligence on board will be developed, and that currently is its prototype is made and under testing. We are also developing the environmental control and life support system, which is also in the engineering model level, and testing is going on. But the most important thing which we are now going to do in August, I think you will hear this news that immediately after this mission, Chandrayaan mission, we will be working on the first abort mission of the Gaganyaan, which is called the test vehicle mission, in which the crew module will be taken to almost an altitude of 14 kilometers, and we will fire the crew escape system and see how it takes the crew away from the vehicle which is going to explode now, and then bring back using the parachute system. So the crew module is currently integrated, final tests are going on, and the vehicle is also ready at Sriharikota, and we are hoping to do this campaign after the Chandrayaan-3.
So ISRO is basically focusing on the safety of our crew more than anything else.
You must also agree with me that that is the most paramount thing, that technically everything is there, but then the handling the danger of any mission failure, which can always happen, and at that point we should be able to bring the crew safely. So there can be only two outcomes in a human spaceflight mission. Either they go to orbit and they come back safely, or if the vehicle don't take them, they still come back safely. There is only two options. There are no other options in between.
So the Prime Minister keeps talking about Atmanirbhar Bharat. Even the space sector, we are looking at that to a large extent. But as far as engines are concerned, are we looking at developing our indigenous engines? Because they say, your liquid hydrogen or liquid oxygen, the combination is supposed to be one of the best for engines or a propulsion model. Is that something that we are working on at ISRO?
See, I think you must be aware that we do have indigenous engines. I think we are not dependent on anybody. See, when we developed the Vikas engine, which was a joint development of India and CNES, so the IP of that engine is also with us. It is not an imported engine. The only liquid engine that actually we recreated is the Russian engine, but that also not through a technology transfer. So whatever engines that we have made in liquid side are made by us. So let us understand, there were no technology transfers of any kind. And entire solid propulsion technology, as you see with the rocket on your side, is made by us. There is no technology collaboration. And the C-25 engine, which is that of the LVM-3 cryogenic upper stage, which uses hydrogen and oxygen, is also designed from fundamental principles here and manufactured and tested and launched. So we have absolutely full knowledge of liquid engines. But what we want further is the heavier versions of the liquid engine, and also working on semi-cryogenic engine, LOX methane engine. So the semi-cryogenic engine currently we have in the process of manufacturing, and one of the engine assembly is under testing in our new facility, and we hope that the testing process for another year or so or more will continue for perfecting the engine, and more models are to be made and tested. And we are also working on a LOX methane engine, which is currently a design is completed, which is a 100-ton engine, which reusability and throttling capability for future recovery and landing type of rockets, so that we are also started working. So it is a very, and also I want to tell you, entire engines used for satellites, all made here. There is no import content of any of this.
So, you've answered in detail most of our questions. One quick last question I'd like to ask you. We've seen the Bezos and the Musks of the world, have their own companies. Private, players in the space sector is growing across, the world. In India, it's still, growing. How much is ISRO looking to nurture, private players, mushrooming in the country, especially in the, space sector?
See, we must understand the private players in the US has been there very beginning. I think when the NASA started the program, there were already private players. NASA came out of that whole process. So, and they were doing the defense equipments and the missiles and the flight aircrafts and things like that. And so those people actually built the first of the moon mission crafts, not a national agency. Of course, national agency was behind all of this. In India, the story is different. There were no industries to start with. The entire work has to be done by ISRO. So the entire rocket building, satellite building actually takes place within ISRO's domain. But we decided that we have to create the industrial system. So in the very beginning of our rocket building and satellite building, we have been partnered with industries, and they were only manufacturing everything. So almost 500 industries are currently doing subsystem manufacturing. But the issue today is that they are not scaled up to a level to understand every niceties or fineness of those elements to do it themselves, which is not there. The capability is not there. You also realize that R&D ecosystem in industry has been one of the not very high in the past. Whereas in US and other places, that is very high. So they are able to create it themselves. So even now you look at the SpaceX and other people, they are being supported by NASA to do all of this. That research support actually comes from there. So the same thing we are going to do here. We are now telling industries, you scale up your, what you are doing today. You are, okay, very good in manufacturing. But now you can get into engineering, innovation, and bringing new products and offer it to the customers on your own for end-to-end capacity building. And ISRO is ready to share whatever we have created over the past in terms of technology, facility for you to do that function. So we have to create markets for them. It is not simply doing some launches for government. We have to find a market for them. We must make them cost effective so that it survives over a period of time. And then we must also make sure that it is not done for India alone, it is done for global market. Then only there will be a possibility of making huge profitability. We are also telling them that don't limit to launch rocket and satellite, but also look at the downstream full work. The economy of this scale is working in terms of delivering end-to-end services. Otherwise, there will be no customers and profitability. We are also looking at innovative work done by them, which is different from ISRO. ISRO has been doing the work in one manner, but there are people who are able to do it in a totally different way, which surpasses our thinking processes. So we have to encourage that process so that they beat others in terms of the new ideas and opportunities. So there are many things happening now, and we are creating a framework of work condition here. So their work is recognized. They are taken to the podium and congratulated. They were given opportunity to do that. They will not be stopped, prevented from doing anything innovative, and further that ISRO becomes a hand-holding brother, not as a boss.
Well, sir, this has been a very intriguing, conversation with you. Thank you for, sharing all of these details and giving us your time. And like I said, the hopes and aspirations of 1 billion Indians are with you. And let's hope that at the end of August, there's good news for all of us Indians. Thank you so much.
Thank you. Thank you so much.
Well, the chairman, of course, has shared a lot of insight into how the Chandrayaan-3 is going to be, how is it going to really work in space, and all those details, of course, have been shared. But what about the other projects lined up for ISRO and, of course, private players in the country? All that and much more coming up after this short break. Don't go anywhere.